નમસ્કાર, હું આદર્શ છું. વેલકમ ટુ આદર્શ એજ્યુકેશન સોસાયટી.
Hello students, today we will study the exercise 6.5. This is the topic of standard 10 chapter number 6 triangles. So let us study the question number 2. What is the question? The question is PQR is a triangle right angled at P and M is a point on QR such that PM is perpendicular to QR, so that PM square is equals to QM into MR. So here we have given is that PQR is a right angle triangle. It is right angled at P. That means P is the negative. From that P, there is a point M on the QR, and if we join that P and M, then it will be perpendicular to the QR. And we have to prove that PM square is equals to QM into MR. So here we know that PQR is a right angle triangle, right? And PM is perpendicular to QR. Now remember theorem number 6.7. What we can write down according to the theorem 6.7, that if all the in a right angle triangle, if we draw a perpendicular on the hypotenuse from this right angle, then all the three angles are similar to each other. That means these two triangles are similar to each other, and both these triangles are also similar to this triangle PQR. So how we have to consider its name, that we have studied in the last class, that for these two triangles we have to take the name as the clockwise direction. So this will be the clockwise direction. In the same way, for this triangle also we have to take the name as a clockwise direction, but for this outer triangle we have to take the anti-clockwise direction, right? So we can write down here is that which all the three triangles are similar, but how can we can write down it? See, this triangle, if we want to write down, then we can write down it as an angle R, triangle RMP, right? Triangle RMP is similar to triangle. For this we can write down it as a PMQ, triangle PMQ, and these two triangles are also similar with this triangle, that is we can write down it as a QPR, triangle QPR. Okay, all these three triangles are similar to each other. We can write down according to the theorem 6.7, right? Now see what we have to prove. PM square is equals to QM into MR. So here QM into MR, QM and MR, both these sides are we have to consider. So we have to take this two triangle. We have to consider only similarity of these two triangles, right? So now if these two triangles are similar, their sides in the corresponds. So corresponding sides are in the same proportion. So here we can write down that PM side PM, that we are taking P to M. So here we have to take Q to M. QM, that is equals to, if we need for RM. So if we take here RM, then here we have to take PM, right? Let us now cross multiply it. So PM will multiply with the PM and QM will multiply with RM. So here we get PM into PM, that is PM square, and here we get QM into RM. So this is the required result, right? So see, in this way we can solve this type of problems, but this thing you have to consider that how we have to name the triangles, right? Interior two triangles we have to take as a clockwise direction, and outer triangle we have to take as a anti-clockwise direction. But one thing you have to remember is that whatever is the right angle, we have to take that name at the middle, right? Like we are writing here RMP. So MRMP, for this triangle, M is the right angle. So it must be at the middle position, right? In the same way, PMQ. PMQ. So M is the right angle, it must be at the middle position. In the same way, QPR. QPR. P is the right angle, it must be at the middle position. So you can remember these things, right? In the same way, let us study the question number 3. Here we have given is that one of the triangle is given, ABD is right angled at A and AC is perpendicular to BD, so that three things we have to prove here is that first one is okay. First of all, let us apply this theorem number 6.7 as it is a right angle triangle. See, triangle DAB is right angle triangle and AC is perpendicular to BD, right? AC is perpendicular to BD. So when we apply the theorem number 6.7, how we can write down the name? See, all these three triangles, this one, and this outer triangle are similar to each other. So to name it, we have to take here clockwise direction, here also clockwise direction, here we have to take the anti-clockwise direction. Right? For this triangle, we can write down the name, that is triangle. C is the right angle triangle, so we have to take C as the middle. BCA, we can take triangle BCA. Right? This is similar to triangle. Now for this triangle, C is there, so we have to take ACD. Triangle ACD. In the same way, for this outer triangle, we have to take anti-clockwise direction. So we can take here BAD. Triangle BAD. Right? So this is, we can write down according to the theorem number 6.7. Now the first thing that we have to prove here is that AB square is equals to AB square is equals to BC into BD. BC into BD. AB square is equals to BC into BD. So see how we can take this, which two triangle we can take here, so that we can find out that AB square is equals to BC upon BD. Right? So here AB side we require 2 times. So AB side is there and AB side is also here. Right? Okay, so we can consider triangle BCA similar to triangle BAD. Right? Okay, now if we write down this side AB here, so we have to take here BC. If we take BC here, we have to take BA, right? BA. In the same way, here now we require BD. So for BD we have to take here BA side. BA, if we consider, we have to take here BD. Okay, now when we cross multiply it, what we are getting? Here we are getting BC into BD and we are getting BA square. We can write down it as a AB square. So therefore, AB square will become equal to BC into BD. BC into BD. So this is the first result that we want. Right? Second result that we want to prove is AC square is equals to AC square is equals to BC into BD. BC into BC. DC. So see, in which two triangles AC sides are there? AC is here, AC is also here. So we have to consider these two triangles. That is triangle BCA is similar to triangle ACD. Right? Now, if we take here BC, this side, then at the proportion we have to take AC side. In the same way, here we required DC. So for DC, if we take DC here, we have to take AC. Okay, AC upon DC. DC. Okay, so when we cross multiply it, again we get the AC into AC, that is AC square. AC square is equals to BC into DC. BC into BC. So this is the second result. Now you can think about for the third result in the same way. AD square is equals to BD into CD. BD into CD. Now think which two triangles here we have to consider, in which AD side comes, right? So AD is not here, AD side is here, AD side is also here. So we have to take triangle ACD similar to triangle BAD. BAD. See, here we required CD side, so from this triangle we are taking CD upon AD. So here we have to take another side we require, that is, okay, we have to take AD two times. So AD is here. So if we take AD, so we have to take here BD. BD, the corresponding sides. And therefore, now we can write down that AD square is equals to BD into CD. BD into CD. Right? So this is the third result. So see, here we are not, it is very easy actually, but the thing is that how to consider the name of the triangle, and that is, this is very actually easy formula, right? You can remember this diagram, that internal triangles you have to take the name as a clockwise direction, and for outer triangle we have to consider name as a anti-clockwise direction. But one thing more, that is the right angle, whatever the right angle, we have to keep it at the middle point, right? Okay, so this is how we can solve this type of questions. This is all about this lecture. Thank you.
Thank you for joining us.